We're going to start by launching the Comm App application using the desktop icon that was placed there during the installation process. Next, once the home screen launches, we're going to go to the automated option, so click on that. Then we're going to select the test equipment that's going to be used to do the automated checks, and that's going to be the IFR for this example. And the radio type, it's going to be a CM300 350 V2 transmitter. Now this applies for both the high power and the low power UHF and VHF V2 CM300 radios. Before we begin, I want to go over a couple things related to the connections that we're going to be making between the computer and the radio equipment and the computer and the test equipment. So we'll start off with the radio equipment. The first thing to point out is to not launch multiple instances of the same automated application. This will create problems. Second, prior to launching the automated application, make sure that nothing's connected to the Ethernet port of the computer. Sometimes that's referred to as the network port. To establish communication between the radio and the computer must be configured to a unique static IP address. Now the Comm App will automatically execute a script that's going to configure the Ethernet port to this static IP address, so you don't have to do anything. And after the automated application launches, use a crossover Ethernet cable to connect between the Ethernet port on the computer and the front panel Ethernet port on the radio. When finished using the automated application, make sure to click on the Enable DHCP button that will be displayed. Now this will execute a second script that will reconfigure your Ethernet port or your network port on the computer to DHCP. Now this is required in order to allow that network port to be used to connect to the FAA network or to the internet. The last thing we'll cover is the connections between the computer and the test equipment. Now, you'll need to use a no modem RS-232 serial cable to make the connection between the computer and the test equipment. The no modem is required. Now, if your computer does not have an RS-232 serial port and a port replicator is available, sometimes referred to as the mini docking stations, use it. Otherwise, if you're using a USB to serial adapter, make sure that the appropriate drivers are installed on the computer prior to you using it. And here's the DHCP enable button I was just talking about. Now to open up the application, we're going to hit this launch button as shown here. Here's the script that configures your network port to the required static IP address. Once the application launches, the software is automatically going to query the radio to establish a communication session. As shown here, it will show green once that connection has been successfully established. Now for the test equipment, you go to this drop down menu that's going to query all of the available COM ports on the computer, and you just select one because you got to figure out which one is the one that you use to connect to the test equipment. You hit the test button here, and this tests the connection between your laptop and the test equipment. If it fails, connection error will display, and you just select a different COM port. So once you select a different COM port, initiate the test once again, and as you can see here, now it's green, which means we're connected to the test equipment, we're connected to the radio. Something to note here is if you're having problems connecting to the test equipment, go to page 2, and page 2 provides guidance on how to verify some settings using the front panel of the test set to be able to remotely connect to it using the RS-232 serial interface. Now we're going to go back to page 1. And as you can see, we're green, and now the transmitter checks are no longer grayed out. You can select them. And part of this automation, you can select each individual transmitter check and perform that specific check individually, or you can perform all of the transmitter checks all at once. And this is what I'd recommend you guys doing. Page 1 is going to show the test setup, and it's also going to include paragraphs similar to 6580.5, where it includes the objective, discussion, and condition paragraphs applicable to all the various checks. So I advise you to read through those a couple times to get familiar with them. Now, it is very important that you set up your tests in accordance with this diagram. If the ports shown on this diagram are not used, or the RF cabling is not connected as shown, the audio cabling is not connected as shown, the automation is going to encounter problems. So make sure to use this diagram to do all your connections and verify that they are made correctly. Once your connections are verified, we'll continue to page 2. Step 2 on page 2 has you offset the measurement frequency for the % modulation using a tone. Now I advise you to do this to minimize interference with nearby operational receivers. Now you can offset plus or minus 50 or plus or minus 25. I'm going to offset 50 kilohertz here, and this is only going to offset for the modulation on tone. Everything else will be done on frequency. I'm going to initiate all the tests as shown here, and the software is automatically connecting to the test set, setting it up to perform the appropriate check, and it's also connecting to the radio to configure it in accordance with the check. Now, something to note here. For modulation on tone measurements only applicable to version 2 radios, you must key it remotely. So key the radio remotely, and the software is automatically going to know when it's being keyed remotely, and it's going to continue with the check. Now this is only required while performing percent modulation using tone. Then the software is going to prompt you, go ahead and unkey the radio remotely now. It's done performing the modulation on tone. And once you unkey the radio, the software will detect that, and then it will move on. Now you notice that the modulation on tone result is already displayed, and now it's putting the radio back to the operating frequency and performing the frequency measurement and the power measurement, and the results are shown. Once it's done, you record the measured values on the appropriate TPR form and verify that the appropriate standards and tolerances are satisfied. If any of the measured values require adjustment, you refer to the individual check to make those adjustments. But before we do that, I want to talk a little bit about this Save Options button and what it does. The Save Options button displays options for the user to be able to create a measured log of the measurements that were just performed. Now, it creates a daily log as a text file that is saved on the computer. Now, the log saves measured values and also site-specific information, and we'll go over some of that information here in a little bit. Now, the log can be useful for reviewing measured data from the radios and also reviewing what test equipment was used to perform the checks. Now, one thing that's important, it also records the radio configuration. All of the software settings that the radio is currently configured to, it saves those as part of the log. Now, why is this information useful? This information can be reviewed and analyzed even when you're not at the site anymore. So that if the TPR stay at the site and you have all that information at the site, and you're back in the office and you're wondering why a radio performed a specific way, or if you had trouble with the radio and you're back in the office and you're trying to figure out why, you can review some of these logs and it'll give you a wealth of information that will hopefully help isolate what's going on between radios. Now, one thing that's useful for second level is to be able to duplicate anomalies in the field. It's always good to be able to know how the radio was configured, what test equipment was used when performing the measured values, even what firmware version the radio was running when it performed the way it did. And a lot of this information is not usually captured on a TPR form. Now, the measurement log is optional, so it is not required. Now, here are the save options. Here are some parameters that the software will prompt and can be used by the user to enter specific information about the facility and about the radio. So for example, the first one here, enter the facility type and ID. Here's where the user would enter whether this facility was a Buick, a RAG, an RTR, an RCO, and that information is useful so we can know where this radio was installed. And then next is the ID of the facility. What ID identifies that specific facility? So on here, I'm just going to enter some information in here as an example. Next, you identify what type of radio this is. Is this a main or standby radio, an ATIS transmitter, so on and so forth. So I'm going to select standby. Here's a timestamp of when the measured log was created. And then comments. Comments are useful information for the technicians to be able to include any information that may be useful later on. So I'm just going to put in here initial checks. These are the as found values whenever I initially performed the checks. Then I'm going to hit save. Now during the save, it's writing this text file and it's saving it on the computer. When finished, today's measurement log will display what was saved. Now it includes the timestamp, the facility type and ID, the transmitter's operating frequency, the identification of the radio, main, standby, so on and so forth, the type of radio. It even includes the serial number of the radio, the test equipment used, and the measured values. Then in addition to that, it shows all of the software parameters that are currently configuring this specific radio, including the firmware that the radio is currently operating in. To close the Save Options, just click the Save Options button as shown here. Now, to adjust any of the radio parameters such as the frequency here, for example, you select on the appropriate transmitter check. Now it'll display a diagram, but again, you don't have to worry about your connections because you've already performed all the checks and all your connections should still be good. Now you can skip to step 5 since we've already had our initial measured values, and it has an automate and a manual option. The manual option shows the current step and options for you to make adjustments to that current step. Now that if you change that current step, it's going to affect the performance of the radio. So if you're out of tolerance or you need to adjust it for whatever reason, you make the appropriate change and then hit the apply change button. Once you hit the apply change button, it sends that new parameter to the radio and then reinitializes that specific check to determine what impact this change had on the performance of the radio. And as shown here, the result will display. Now you can continue to do this until you get the measured value that you're looking for. Remember to hit the apply change button to make the change to the radio and reperform the check. The second option to make adjustments to the radio or to perform corrective maintenance is to do the automate. Now this is the desired frequency because this is the operating frequency of the radio. By hitting the initiate button as shown here, the software will automatically configure and change the parameter of the radio associated with the frequency until the test set measures as close as possible to the operating frequency. Now it's not always going to be right on, but it's always going to get you within the appropriate tolerance. And as shown here, it got us within 11 Hertz, which is well within our initial or operating tolerance. Now what you would do here is actually record your new measured value on the appropriate TPR and verify that it meets the appropriate tolerances. Next, we're going to go to the power output option and adjust the power output of the transmitter. Now page 1 will always show you a diagram. Again, we don't have to worry about our connections because those connections have already been made. We can skip to step 5 because we already have our initial power measurement. Again, you'll have two options: to automate it or manually adjust that parameter. Now, it gives you the current step level associated with the power and options for you to make adjustments to that parameter. You can use the knob as I've already shown, the up and down buttons, or you can manually highlight and enter the desired step level. Once the desired step level is shown, you hit the apply change button to send that change to the radio and reinitialize the power output check. That will tell you what the performance of the radio is now that that change was applied to the radio. Now you see here that the power went up, and you continue to make adjustments and hit the apply change button until you're within the power level that you want. The second option is to automate this process. Instead of you making the changes, you just enter your desired power level. And once that's entered, you hit the automate adjust initiate button, and that automatically sets the software to adjust the power level of the radio automatically until the measured value on the test set is as close as possible to 10 watts. And again, you may not get exactly what your desired level was, but you should always get very close, enough that you'll always be within tolerance. And as shown here, we wanted 10 watts and we got 9.8. Now you would record this new measured value on the appropriate TPR. Next, we'll go to the modulation on tone. And again, here's a diagram of how to set it up. You're already set up because we've already done all of the checks. And remember, you're going to be remotely keying the radio for this check. And this is only applicable to version 2 radios when performing modulation on tone measurements. Again, you can skip to step 5 and you can manually or automatically adjust the desired modulation level. Now, the manual option will display a current step level and options for you to make changes to that current step level using the knob. You can also use the up and down buttons, or you can highlight and manually enter your desired step level. Once it displays, you hit the apply change button to send that new parameter to the radio. But remember to always offset when using modulation on tone to minimize interference with nearby operational receivers. So we're going to offset by 50 kilohertz, hit the apply change button. We get a prompt that says to complete the check, key the transmitter remotely. So you key it remotely. The software detects that the transmitter is now keyed remotely. It performs the check, and then it'll prompt you to go ahead and unkey the transmitter to finish the check. And once you unkey, the software will notice that it's unkeyed now, and it will display the result. So that change correlated to an 83% modulation using tone. And you continue to do this until you get the desired modulation level. Or you can automate this process. You can enter the desired modulation level that you want. For this example, I'm going to use 90, let's go with 95%, and that's my desired. Then I hit my initiate button to automatically begin the auto adjust process. And at this time, the software will begin the setup to the test set, the setup to the radio to perform the check. And it'll prompt you to remotely key the transmitter, since we're doing modulation on tone. Once you remotely key the transmitter, the software will notice that the transmitter is being keyed remotely, and then it's going to automatically adjust the modulation step level on the radio until our test set displays or measures a modulation level as close as it can to our desired. Now, once that process is finished, the software is going to prompt you to unkey the transmitter so that it can complete and display the results. And as shown here, is prompting me to unkey. I'm going to unkey the transmitter. Once that I unkey the transmitter, the software will notice that and it will display the results as shown here. And it got me within 1% of what my desired modulation level. Now, the last thing to do is to record this new measured value and verify that it's in accordance with the appropriate standards and tolerances. Now, the last thing we want to do here, since we made changes to our frequency, power, and modulation levels, we want to save these new levels and the new step levels associated with the changes in performance. So I'm going to enter my comment accordingly. I adjusted the frequency, I adjusted the power output, and I also adjusted the modulation level using tone. And then I'm going to hit my save. And that log now is going to be saved with the new timestamp. And again, this is useful information so that you can identify what changes were made to the radio, what kind of step levels had to be changed to get to this new performance. Very useful information for troubleshooting and for isolating anomalies, for trending transmitter performance, trending based on firmware, based on how long the radio's been on, when was the last time it was powered down, so on and so forth. And so I think we're beginning to be able to use new tools for trending performance of radios, and this is just one of those tools. Again, this is optional, but I think you'll find it very useful if you actually use it. Now, to close the save options, just click on the close save options button as shown here. Hopefully you got a general idea of how to use the software and what the software can do for you. I'm going to hit the X button to exit out of this application, and as shown here, the main program will always be running in the background. Now, before we end, this is the DHCP enable button that you must click once you're done doing maintenance. And this is required in order for you to use that network port on the computer to connect to the FAA network or to use it to connect to the internet. Once you click on that button, a script will launch that will automatically enable DHCP on the computer as shown here. Now, before we go, one last thing. If you want to review measurement logs, the way to do that is you click on this measurement logs button, and it doesn't require you to be connected to the equipment or anything. This is just for you to be able to review all the logs that are currently saved. You click on the folder icon as shown here, and it'll give you a list of measurement logs that have been saved. And here's the daily log that we just created today. And once you hit OK to select that file, you go to step 2 and you open the file by clicking on the open file button. Then go to step 3 and review the measurement log associated with the file that was selected. And here's our measurements that we just performed, timestamp and additional information. Now, if you want to review additional logs, just click on the folder icon, select the date of the log file that you want to select, hit the open button to review and be able to access that information. Now, I added a default example measurement log as part of the installation for you to get an idea of all the various settings that are logged and saved for all the various transmitter types and receiver types that are supported. And so you can review that log just to get an idea of what's being saved, and so you can get more familiar with the information that can be useful later on down the road. Then we click on the automate button, and that closes everything out. And to close the entire software out, you click on the quit and exit, and that'll close it down. If you have any questions, don't hesitate to call us.